Welcome back to MPB's Boot Camp for Algebra 1. I am Ms. Killen. We're going to dive right on in today's lesson. We have working with quadratics. We're looking at multiple standards for this quadratics lesson. So let's go ahead and see what we've got. We need to remember how we factor, how we take the square root, complete the square, and use the quadratic formula. We're going to look at some MAAP questions today to see if we are getting ready and we have all the standards together for the end of year or end of course test. Power of reading carefully. We want to make sure with these different passages we have, these different problems that we have, we are reading carefully, understanding what the problem wants for us and what the problem is giving us. So here we go. For which equation is the solution set 0, 2? So what we're going to do here is we are going to take our x value and plug it into every single one of these, or we can go to Desmos, put each one of these in and see which equation has this as a solution. Now, you can put this in Desmos, you can put this in your calculator, you can plug in your 0 for your x values. All of those ways will give us our answer, and they're wonderful ways to use, so it's whichever way you are more comfortable with. Now, when we look at this problem, we see our 0 is our x value, so when we plug it in, we find out that this would be the equation that has that solution. Like I said, there's multiple ways to do this. You have Desmos, you have calculator, or you can just plug it in, whichever way you want. Here we go. What is the sum of the solutions to the quadratic equation? The sum. Okay, for this one, what I'm going to do is I'm going to make sure that I have what my quadratic equation is, and I'm going to pull up our tool of Desmos, and I'm going to plug this in. So I have x squared minus 4x minus 5 equals 0. All right, so here is what I have. So let's graph this and see how far it goes up or down. So we do not see where it's going to start rounding out. So now let's go back and look and see what it's asking us to do. It says, what's the sum of the solutions? Well, I see I have a crossing here and I have a crossing here. When we have these solutions, we are looking at our x values. So I'm going to have, and I can use Desmos to do, I have -1, sum being addition, plus 5, and I get a 4. So when I go back to my problem, I can say that my sum is 4. So I am using my Desmos not only to graph, now I'm using it to calculate. So this Desmos tool is multiversal. Here we go. It says, don't forget the quadratic formula song. Now, in our multiple lessons that we worked with quadratic, we learned what that song was. Remember, you can always pull it back up on YouTube if you need to. You can pull back that lesson, but you want to make sure that you're understanding and remembering what that quadratic formula and song was. Here we go. Trinomials. Trinomials of the form ax squared plus bx plus c are unfactorable over the set of real numbers if b squared minus 4ac is negative. Which trinomial or trinomials are unfactorable? Now, we learned what this was. This is our discriminant. And it says if it is negative, and we have this in our notes, if my discriminant is negative, so it would be less than 0, that means I have no solutions, which also means it is not factorable or unfactorable. Okay, so one way that we can do this is plug each one of those into Desmos, each one of those into the calculator, and see if there is one that does not touch or cross our x-axis, right? So as you put these in, notice which one we see that we can and we cannot factor, or that we can and we cannot see cross or touch that x-axis. I'm going to do it this way. I'm going to say I can factor out a 4 on both of those on A. On B, I have my A, it's bigger than 1, so I would do what? Bottoms up. So I'd have x squared minus 2x plus 9. Are there factors of 9 that will add to give me a negative 2? No, there's not. So I know this could be possible one answer. But we've got to make sure that we're looking at that little word or. So is there a factor of 1 in number C that I could add to get a negative 2? Well, factors of 1 are what? 1 and 1. 1 times 1 is 1. So when I take and you put this in your calculator, so I want them both the same because it's addition, and I'm looking to get a negative 2. So if I put negative 1 plus a negative 1, I do get a negative 2, so this one is factorable. Let's look at D. I could factor out a 5 from both of those terms. So for this problem, B is my only answer that I can truly factor. Good job. Let's look at the next one, the area of a rectangle. The area of a rectangle can be expressed as x squared plus 7x minus 60. What is the factored form of x squared plus 7x minus 60? Now, there are multiple ways you could do this. You could work this problem, you could come up with the different factors, but sometimes we're kind of going against the time clock. So let me show you an easy way. I'm going to pull up my Desmos. I am going to plug in that equation. So it was x squared plus 7x minus 60. So I'm going to, here is, so to speak, my graph. Now what I'm going to do is each one of my different answer choices, I'm going to plug in here. Now which one is the factor should graph over it. So whatever we put in here that's the factors will graph over our red mark. So let's look and see what we got. So the first one, we have x plus 4 and x minus 15. The blue does not graph over the red, so that one is not the answer. Let's go to the next one. I have x plus 6 and x plus 1. It's smaller and more condensed than our red one, so it is not the answer. Let's look at the next one. X plus 12 and x minus 5. Whoa, where did my graph go? Oh, there's my red one, but then when I plot this one, it plots right over the whole graph. So obviously C can be my answer. Let's try the last one just to check. Here we go. So I've got x plus 20, and I have x minus 3. Nope, it's a lot bigger, and it's moved to the left. So obviously my answer is C. So here would be my answer. Good job, guys. So the next one says the area of a rectangle lot. The area of a rectangle lot is represented by 8b squared minus 22b minus 21. If the width of the lot is 4b plus 3, which expression represents the length? Now, we're going to answer this question the same way that we answered the previous question. I'm going to plug in my whole equation. Then underneath it, I'm going to plug in the first part that they gave us. And then I'm going to add each part to see which one is going to make it graph on top of each other. So when you pull up your Desmos, you're going to put in your original, and then you're going to put for the second part what they gave you, and then add each answer choice. Y'all go ahead and do that now. All right, so when you plotted this and you found which one is going to go right on top of the other, you noticed that your answer was what? Is that what you got? Let's double check. 4b plus 3 times 2b minus 7. Let's FOIL 8b squared negative 28b plus 6b minus 21. Put these terms together. You can always plug that math into your calculator if you're unsure. Negative 28 plus 6, and I get this as my answer. And is that not what we started out with? So you want to make sure, even though you're using your technology, even though that you put it on Desmos and it graphed the same, you still want to come back and double check. Remember, you always want to measure twice before you cut once. That's just a good rule of thumb. All right, so let's see what else we've got. All right, given the polynomials, let's see. Given the polynomial 4x squared plus 12x plus 9, which option correctly identifies a 0 and a sketch of the graph of the function defined by the polynomials? So I plug this in to Desmos, and let's do that. So when I'm going to plug this into Desmos, I have 4x squared plus 12x plus 9. So I have what my graph is. It's opening up, and here is my 0, negative 1.5. So let's go back and look and see what we've got. Obviously, this and this are not the answers. So now, these two look the exact same, but I have to remember that my 0 was what? Negative 1.5. So what is negative 1.5 put in as a decimal? Negative 3 over 2. This is my answer. You want to make sure that you don't go by looks alone. You want to make sure that you're taking that negative and making it into a fraction and making sure that all of your numbers are equivalent. Good job. I am so glad that you came back to review with us, getting ready for that end of the year test. And as always, thank you for joining us and have a great day.